Welcome. And today we're going to start our journey into calculus. And as we start our journey into calculus, let's start with a preview. Let's back up before calculus. So one of the biggest things that we discuss in calculus, one of the biggest things that where calculus gets its birth from, is the question of rates of change. Okay, that is a huge thing in calculus. Okay, it's a huge thing when we talk about things like physics. You know, rates of change in the trajectory of a falling object, or a thrown object, or a launched object. The change in stock prices. The change in human behavior. There are so many applications where this idea of a rate of change comes from. That's very important to answer. Okay, now in algebra, right? In algebra, we discuss rates of change. In pre-calculus, you discuss rates of change. And so, where does it come from? Well, we look at these examples, and so we have these three functions. And so we want to find the rate of change. Well, how do we find the rate of change in algebra when we're dealing with a linear function? Well, it's quite simple. We need 2 points, right? So we can take any 2 points on a straight line, and we can calculate what? The slope of that line. And the slope of that line represents the rate of change of that linear function. Why? Because the rate of change is constant. We know that, right? Hence the linear function. We know that for every linear function, the rate of change is constant. So we can take any 2 points and we can calculate the rate of change by finding what? The slope of the line between those 2 points, because again, it's constant. Okay? Now, if we're given the function, then we know that again that the slope represents the rate of change, right? So, for example, in this example, we have g of x is equal to x over 2 is plus 1. Okay, so that we know that the slope of this line is 1/2, which means for every 1 unit you move to the right, we know that it's going to go up what? 1/2 of a unit. Okay, so every unit you go to the right up, it's to the left, or excuse me, to the right, it's going to go up 1/2. So 1/2. So that's what the 1/2 stands for. Okay, here we know that the slope is 2, which means that, or negative 2, which means for every unit you move to the left in the x direction, you're going to go down 2 units in the y direction, negative 2 units down, right? So negative 2 units. And then of course, f of x equal to negative 2 is a constant function. Okay, so it's going to have a horizontal line at y equals negative 2. So all of these, you can find the slope, right? Or if you're given 2 points, you can find the slope of any straight line. But what if we look at something like this, where we have k of x equals x squared? So we have this parabolic shape, this parabola, right? Well, here's the thing. The rate of change, i.e. the slope, is not constant, because notice if you move left to right, it decreases at a much faster rate, and then it starts to flatten out. So the rate of decrease decreases, right? It flattens out, and then it becomes constant for a moment here, and then it starts to increase slowly, and it starts to increase more rapidly as you move further to the left. Okay? So the question is, and this is where the tangent line problem comes in, is that the fact is that the rate of change, the slope, is not constant here. It changes depending on where you're at in the x direction. So the question is, how do we solve this? And this is where people like Newton and Leibniz developed independently the study of calculus, the the math of calculus. And that's what we're going to start with today, or next time. We're going to get into this, and we're going to start saying, okay, well, how do we solve this? How do we take care of this? How do we approach this tangent line problem? Because unlike these examples, I need 2 points, and 2 points will give me the slope of the line because the slope of the line is constant everywhere. So I can pick any 2 points on the line on a linear graph, and I'm good. I can't do that here, okay? Because wherever I pick 2 points, the slope of that line, that secant line, is going to be different. So what I need to know is if I want to know what the slope of the line is at a particular point, I can't do that with the tools that I've learned up through pre-calculus. The only way we can answer the question of the slope of a tangent line, or the slope of a point, right? The slope of a point is to use calculus, okay? And that's where we're going to start. We're going to start on the next video. We're going to start in how do we approach this problem and how do we solve it, and how did Newton solve it or Leibniz solve it. They approached the same problem a little differently, but came to the same result independently, okay? Which is kind of interesting because they both developed the study of calculus. They both developed calculus independently about the same time, even though they lived very far apart from each other. So, other than that, have a great day, and we'll continue next time.